Good morning, my YouTube viewers. Crystal here. I'm going to try to make you another video this morning because the last video I made, they had a code review on it. The screen turned green. I don't know how it turned green, but it did. I've got the camera turned off this morning, so that might help. Anyway, because I haven't done anything. So I'm not presentable, so I had to turn off the camera so you don't have to see that I'm not presentable. What I'm going to make on this video this morning is, let me see if I can find it, is I took the COVID-19 data set off of the GitHub account of John Hopkins. And this data set is updated daily. So because the data set is updated daily, that means that I don't have to go in every day and reload the data set. So that's a good thing about that particular data set. I don't have to reload it myself. But the only thing that this data set gives you, it gives you the country, it gives you the latitude, the longitude, it gives you the region, and then it gives you the number of new cases for that day. And I suppose if I wanted to see the new deaths, I could look up the website for the new deaths as well. So that's good. That's good that I don't have to update it every day. But I just decided that I was going to look up the new cases. I could look up the new deaths if I wanted to, and I may very well do that. I may very well look up the new deaths in another video. But at the moment, we're just looking at the new cases. I made this program on Google Colab. And the nice thing about Google Colab is the fact that it has Python and the libraries already installed on it. But one not so nice thing about Google Colab is the fact that it doesn't, sometimes it doesn't have the most current version of the library installed on it. So I don't know why they do it. I don't know why they're not installing the most current version of the library. And because they're not installing the most current version of the library, there are some of the functions, if you want to use them, then what you're going to have to do is you're going to have to go into Google and install the most current version. But we didn't have to do that today. So after I made the program on Google Colab, which is a free online Jupyter notebook, I named it JH because that's John Hopkins, because I'm using the John Hopkins website now. And it's on a GitHub account. I loaded my libraries. The libraries that I loaded were Pandas, NumPy, Matplotlib, and Seaborn. Pandas is a library made on top of NumPy that allows you to manipulate the data frame. NumPy is a mathematical library. Matplotlib is a graphics library. And Seaborn is also a graphics library that's made on top of Matplotlib. So after I imported my libraries, what I did was I imported my file. The file is a CSV file on a GitHub account, so you can see the file that I imported. It's from John Hopkins. Apparently, it's updated daily, so that means I don't have to update it daily. So you can see this particular file, it has 273 rows times 388 columns. So I don't know how they got 273 rows out of 388 columns, but they did. And so each column, you can see you've got your province and your state, your country, your region, your latitude, your longitude, and then you've got the new cases. but these cases are cumulative. They are cumulative. So the cases that you're getting are the total cases. You're not getting you're getting total cases. You're not getting um new cases for that day. So as the previous website I was using, they had a column for new cases for that day and total cases. But in this particular CSV file, it's just total cases. So I wanted to create a map. So I took the latitude and the longitude and I created the map. So this is a map. I did actually look on Plotly to see if there was the possibility that I could like put all these dots on a world map, but I didn't see anything on Plotly that would enable me to put all the dots on a world map. I think that if I had wanted to use the CSV file just for the United States, then I could have used plot map to plot the cases on a map of the United States, but because I used the world, I didn't see a world map on Plotly, so I just let it go. But this is like representative of a world map of all the different locations where they tested for COVID. I also put code in here to find out which countries this CSV file covered. And then so we've got all the different countries that this CSV file covers. And it's got 192 countries, whereas when I was working on the other CSV file, it also started out with 192 countries. And then somehow or other, I didn't look at it for about a month. And then when I went and looked at it again, it had 200 countries. So I don't know where they got an extra 8 countries, but they did. So we're going to impute the missing values in province state. So I just decided that all of these province states that said NAN on it, I decided that I was just going to put a code called country in it just to let you know that it was an actual country. So if it didn't say have a province state in it, then it just got country. And so I decided that since I'm living in the United Kingdom, I wanted to filter out the United Kingdom. So I filtered out everything that said the United Kingdom. And this says, and now, at least now we know what are all United Kingdom territories. They had Anguilla, Bermuda, British Virgin Islands, Cayman Islands, Channel Islands, Falklands Islands, Gibraltar, Isle of Man, Montserrat, Turks, and Caicos Islands, and then you had the UK. What's interesting about Isle of Man, if I wanted to look up Isle of Man, so Isle of Man is on 260. It's 1, 2, 3, 4 up. So apparently Isle of Man, it doesn't have a lockdown anymore. So 1, 2, 3, 4. Since they don't have a lockdown anymore, and they said they had 435. So 1, 2, 3, 4. Said they had a total of 435 cases of COVID-19. So since they don't have lockdown anymore, I thought, oh, well, that would be interesting to see how many cases of COVID-19 they had. So their lockdown is over, but I believe that their borders are still closed. And the UK has finally decided to close the borders. So that's one thing that, really was a bit upsetting about this whole business, because the UK went into lockdown and all the shops were shut and we weren't allowed to go out, but their borders were still open. They were still allowing people into the country who had COVID-19. So it just completely negated any lockdown efforts that were made. And so now the UK's finally decided to close the borders. They're finally saying that if you come into the country, you have to quarantine at a government approved hotel. And they're going to be, well, they're definitely going to be fining people who don't take the COVID-19 test before they come into the country. I've heard something about prison terms as well, but finally, after almost a year, they finally closing the borders. They're finally making people quarantine. And why didn't they do this before? Why did they wait a year to close the borders? Why did they wait a year to say that oh, you're going to have to quarantine? Why didn't they do that automatically? So we were all in lockdown. All the shops were shut. We weren't allowed to go anywhere. But they were still allowing people into the country. They weren't testing them to see if they had the COVID-19, and they were letting them come into the country. So I'm glad that they're finally doing something about this. And last I heard, there were over 110,000 deaths attributed to COVID-19 in the UK. So now what we're going to do is after we've done that, and I've told you a little bit about my frustration of living in the UK, living in lockdown when they were still allowing people into the country to spread the disease. So finally, what we decided we're going to do is we're just going to look at UK. We're not going to look at anything else. So this is UK. Our latitude is 553781, and our longitude is -3436. And so you can see we've got country and UK, and we've got all this time series data, and it just goes up and up and up and up. So now what we're going to do is we're going to create a time series. So we created this new time series called DF-UK, and we're dropping province, state, country, region, latitude, longitude. So now the only thing we have is the time series data, but we know it's for the UK. Now what we're doing is we're using the melt command, and when we use the melt command, because this is going to be for a new time series, the variable name is going to be date, and the value name is going to be total. So we've got date and total. So now what we've done is we've taken this John Hopkins CSV file, and we have converted it to a univariate time series file, data frame. So now what we're going to do is we're taking date time, and we converted the date to a date that the computer will look at, and we've used the date as the index. So now that's what we've done, is now our date is our index. So now this is a genuine univariate time series file. Now what we're going to do is we're going to do a little bit of feature engineering. So dfuk.load equals total minus 1 equals dfuk.load total shift 1. So that means the day before. dfuk float today equals dfuk float total difference. So what that does is that's telling you the difference between yesterday and today. So total is today, and total minus 1 is yesterday, and today is different. So the difference is 14104. And I did actually check this because I have I look on this Google web page every single day, and when I look on this Google web page every single day, it tells you how many cases they had that day, and it's correct. It's correct with what the Google web page says. So now what we've done is we've graphed our time series. So this is very similar. Well, it's not similar. It's the same as the previous graphs that we have been making. So you can see here, we've got our first lockdown here where we didn't have very much and we were like, oh my God, we're in lockdown. And then we've got our second lockdown here. And this is when this UK variant came into being. And the UK variant is much more infectious than the original disease. And that prompted the second lockdown. And then what happened was they loosened the restrictions over Christmas. So when we loosened the restrictions over Christmas, this UK variant just went haywire, and so it prompted the third lockdown. So we're in the third lockdown now, and now the rates are going down below. So we're getting the injections. We're getting the injections, and finally, after all this time, the UK's decided to shut the borders. They've decided that everybody who comes into the country has to stay in a hotel at their own expense and isolate, and they're going to have to pay for the hotel. They're going to have to pay for all the tests and everything like that. And they should have been doing that before, and it's because they didn't close down the borders and they allowed people into the country who had COVID-19 that has created this mess. Because there's other places where they had a lockdown and they shut the borders and they enforced lockdown, and these places are no longer in lockdown. The Isle of Man is one place in particular. So now what we've done is we've created a lag plot, so you can see that there's definitely a correlation between the total and the total minus 1. And there should be a correlation because it is total and total minus 1. Now we've done a correlation matrix, so you can see that the total and the total minus 1 are related. And this is something I don't really understand, that we did an autocorrelation plot and nothing's coming up on the autocorrelation plot, and it just says 0, and I'm not sure exactly why that is, but I went ahead and put the chart there. Now we're doing some more feature engineering. So df equals df float, drop, total minus 1, axis equals 1. So that means now you just have the date and the today. And df UK lock, today minus 1 equals df UK lock today shift. So we shifted it. And df UK 1 difference equals df UK lock today diff. And then so we check that. And so now you've got a difference between the two. You've got a difference between the two today and today minus 1. So today was on the 8th of February was 14,104, and today minus 1 was 15, and so that's a difference of negative 1741. And I did actually check that on Google, and that was true. It did actually give you the true figures. So now after we created another website, done some more feature engineering to have today and today minus 1 and the difference, we define our training and our validating set. So X train equals DF UK 2020 drop today, axis equals 1. Y train equals DF UK log 2020 today. X val equals DF UK 2021 drop today. And Y val equals DF UK lock 2021 today. So, and then we check the shape on that. And so you can see that we have our training and our validating set. Now what we do is we decided we're going to use linear model. So we used linear model. Model equals linear regression. Fit X train, Y train. print model score X and Y train, we got 100%. I don't know how we got 100%, but we did. We did. And then we predict on the validation set. Y-pred equals model predict X val. Y-pred equals Y-pred S type int print model score X val Y val. We got 100%. I don't know how we got 100%, but we did. So now we check our root mean squared error, and we had a very low error. We had an error of 32%. And that was on Y val, Y-pred squared false. And then we check the data frame. And then so this is you can compare the actual values against the predicted values. And then we check our graphics. So we've got our graphics. We've got our actual values against the predicted values, so you can see that. And we have another graph where we have the actual values against predicted values as well. So that's what it did. It gave us 100% accuracy. I don't know how it did that, but it definitely did that. And so I wanted to make a video to show this to you. I certainly was not expecting to get 100% accuracy. So I'm going to be making a blog post on this, and when I make the blog post, I will give you the link to the I will give you a link to the GitHub account so you can look at it. So you'll have to read the blog post if you want to get the link. So thank you so much for watching this video. If you want to keep receiving videos, then please like, subscribe, and share. If you press onto the bell button beside the subscribe button, then you will receive a notification whenever I have made a video, and that way you'll stay up to date on all the videos that I make. If you like the work I do and you want to support me, I've got my PayPal account with my email address in the description box down below. So thank you so much for watching this video, and I look forward to making more videos for you in the future.